Hey. Okay, so let's talk about the first possible exercise, uh, which asks the following. Generate a 12 by 12 square grid with a cell size of 3 units. Then you have to draw a curve in Rhino that passes through that grid, and in each point of the grid, you need to generate a circle that has a radius of 0.1 times the distance between the center of the circle and the curve that you drew before. Right, so the size of the circle depends on the distance between it or its center and the curve that you draw. And it's a certain percentage, basically 10%, because 0.1 is basically 10%. Anyway, let's look in Rhino and do this. So, first thing, it asks that we generate a 12 by 12 square grid with a cell size of 3 units. The grids you can find in vector, see, or just double click and type grid. I mean, I have more, I think a few options more because I have some plugins installed. But anyway, in vector, you can find grid and you can find square grid, which is the one you can use in here because I'm asking for a square grid, but you can also use a rectangular grid, and I'm going to show you how to use a rectangular grid because it's basically the same thing. So it needs the size of the cell, see, size of grid cells in base plane. And we said that the size is 3. So it's a square grid with a size of 3 by 3. So we're going to put 3 in both of these input hooks. And then the extend means how many cells on each direction. And I said 12. So we're going to put 12 in both of these. All right, now we have the grid. And this component outputs cells and points. We need a point. The cells are basically the rectangles or squares in this case. All right, so what next? What do we have to do next? Draw a curve in Rhino that passes through the area of the grid. Okay, this is quite simple. You just pick one of these two. Interpolate means the points that you pick are within the curve, and this is control point curve. You pick points outside of the curve. You might ask, why would you use this one? Because this is actually how geometry is defined in Rhino, because it is a NURBS modeling software. If you don't know what NURBS is a type of defining geometry. Just look it up. So I'm going to use interpolate curve, but you're going to see that even if I put these points within the curve, afterwards when I click it, I actually have points outside of it. Anywho, so I have the curve now, and now I want to do circles in each of the points, so these points of the grid, and make that radius be a certain percentage, 0.1 or 10% of the distance between the center of the circle, which is the point or the points that are on the grid, and the curve. So let's see how we can draw circles. At curve, you might imagine that this component belongs. And in primitive, we have different types of defining a circle. This one, which is named just circle, needs a plane and a radius. All right, so the plane is basically, or for the plane, we can use the points that are generated here. Because even if it actually needs a plane being basically two axes that intersect in a point, if we input points where a component needs planes, it will convert those points into horizontal planes that have the center where those points are. So, long story short, we can use just points and we're gonna get some horizontal circles that have the center where those points that go into the plane input are. Right, so for radius. Now it has a default value of 1, but we want it to basically be a 0.1 of the distance between the center of each circle and the curve that we defined beforehand. So these are the centers of the circles, right? And in order to get the closest point on the curve, so that we get the distance, we're gonna search for a component that has within the name closest point. So closest point. We just double click on anywhere on the canvas and search for closest point. We get several options, but it's quite easy to pick the one that we actually need, which is this one, curve closest point. So we have these points and we have the curve, which we need to make a reference of within Grasshopper. And to do this, we can either right-click it and set one curve and select it within Rhino, or I would advise you to use one of these geometry inputs or curve input if you want it to be more specific. And this just holds that the reference geometry. It's like a recipient, but you can use the same recipient further on in the algorithm if you need it. So I think it's better like this. So right click it, set one geometry, and we choose this one, the curve, and we input this into curve. And now we have the following. We have the closest points on the curve. So for each of these points, it gets the closest point on the curve. We have parameter, which is basically sort of the position of each point on a local coordinate system for the curve. We don't really need to bother with this at this moment. And we also have the distance between the initial point and the closest point of the curve. And that's what we actually need. If this component didn't output distance, we could have used distance component between these points and these points, but we don't really need this because we already have the distances here. So I'm going to delete this and just plug this in. Although this is not what I need, because now for each circle it makes the radius the same as the distance. So basically each circle is tangent to this curve. But we want the radius to be 0.1 times the distance. So in order to do this, we're going to go at math, choose multiply, and we're going to put this information through multiply. And here in B, we're going to double click and use a slider of 0.1. Bam. And now it's finished. We can also select all of these, middle click and hide them. So we only get the result, and we can also then play with everything. We can modify the curve. We can make the size of the cells bigger or larger. We can also make more elements if you want. Ooh, that's a lot of elements. And so on. We can also modify this slider if you want it, but we can double click its name and then here maybe choose, 1 is fine. So that it goes from 0 to 1 and maybe have 2 decimals. And now we can also play with this value, so that it's a bigger or smaller percentage of that distance. And that's about it.